So okay, so today we have going to look at calculate the volume and surface area of a cuboid, edge wedges, cylinder, cone, and spheres. Okay, then you solve example on the shape using use in the marine environment. So to start off, let's look at something we are more familiar with. It's a cuboid. So a cuboid has 6 rectangular face. You can see it in the diagram at right angle at each other. Because they are all flat surface and upright edges, so the cube is special formula for find the volume. It's just length and width and height. This will be the volume of a cuboid. Now, how do you find the surface area now? So, to find the surface area, let me show you the surface area is actually, I will show you all the surface here. So the one highlight in yellow, okay, highlight in yellow is a top and bottom surface. So you have a top and bottom surface. So top and bottom surface is highlight in yellow, and then there are side surface, highlight in green. Side surface is actually this one, okay, W times H here. This side surface here. Okay, side surface, these two in green color. And then I'm going to use blue surface, another surface here. So this blue surface actually is this one, front and back here now. Front and back. Okay, so this is the front and back here. So okay, front and back, this one, right, front and back. So there are 2 pieces each, so that's why times 2. Okay, so this is about the cuboid. Okay, how to find the volume of a cuboid and the surface area of a cuboid here. Okay, then the next one I want to talk about is wedges. Okay, what is a wedges here, right? So let me clear this first. There are too many information here, so I will clear this first wedges here, right? So the wedges has 5 faces now. Where are the 5 faces here? The 2 at the bottom, 2 at the bottom there, and top. Okay? The 2 triangle faces, one at the top and the bottom, so there's a triangle base, and 3 rectangular faces, vertical one. Okay, you can see 3 of them. One, actually 2 in front now and 1 at the back. Okay, 3 in front now. Okay, the side, the length. Let's say the length of a triangle is ABC. Okay, ABC here. So the wedges, the volume of wedges is actually base area times height. So base area, you know how to find area of triangle now. So last time we mentioned about area of triangle, you find S first. Okay, you find the value S here, which is sum of the 3 sides here. Okay, sum of 3 sides here. A half of A plus B plus C. This is called S here. Then the area of triangle is S times S minus A, S minus B, S minus C. Take the square root. This is the area of triangle. And then you find the height. Okay, the height is actually this one. The height here. Okay, the area of triangle is actually, I use this one, area of triangle here. So From there, you can find the volume of the wedges here. Now, how do you find the surface area of the wedges here? So there are five surfaces, right? The one on top and bottom are two triangle surfaces, right? So what is the perimeter of a triangle? Surface area, right? Surface area of the triangle we know is actually half of, we find the surface area is actually this triangle on top and triangle below. So the surface area is at the one triangle on top plus one triangle below, which you can use this to find the area of triangle here. Okay, and then I want to find the surface area, right? And then this one. The triangle on top is this one. The two on top, two below. Which is actually from here. And then the side area, the three side them. How to find the side area here? So all of them, for example, you take this side area. The length of this one is A. The height is H here. So the length times height, right, is the area of the rectangle. So A times H here. So this one is A times H here. Then you do another one for another side. B times H here. Okay, B times H based on height, right? B times H here. And then the one at the back, C there. C times H here. Right? So this is how you get the area of this rectangle is actually A plus B plus C times H. Okay? So this is how you find the area of total area of the wedge here, right? Two at the top and the bottom is a triangle, and then A plus B plus C times H. Times H here is a 1, the side area. So let me WhatsApp this page to you here. So let me skip this one first. Okay, this is something extra information. Okay, so WhatsApp to you. Okay. All right, then go back to the start here. So I'm going to go through the first example with you. Okay, so this example is about the wedge now. Okay, you see the shape look like a wedge here. Okay, and let's do the question first. So you have open tank. What does it mean open tank? Means the top is open now. Okay, the top is open, so that the top has no surface, right? No surface in the top here. Open tank means no surface and close on top. So it's on top, no surface on top there. And you fill up full of water. In this case, it's a A, B, C, and D, E, F are two identical equilateral triangles. Okay, A, B, C, and D, F. So these three sides are equal length. Identical equilateral triangle means all sides are equal, right? So each one side, AB equal to 5. Okay, AB, BC, AB, BC. So all sides are 5 here, right? So these are 5. Okay, AB and BC, all sorry, AB, BC, AC, DC, EF, all 3. So this is 3 here. So this is 3 here, all side length 3. Right? And then DAD and BECF. Okay, AD, BE, and CF all 5. Find the volume of a tank. Okay, so first part, find volume of tank, right? Let's do calculation. Part A, volume of tank, right? So how to find the volume of tank? Volume of the tank is actually, if you look carefully, just now I mentioned this, volume of tank here, okay? Volume is a wedge, is a base area times height, right? Base area times height, okay? Volume of which is base area times height. So volume of tank, base area times height. So what is the base area now? Base area is actually if you turn the wedge upside down, okay, because this one doesn't look like a wedge, yeah? The base is a triangle now. So you turn it upside down, you look at this one, it's such a, you have something like this. Okay, down, turn it upside down. So, okay, turn it upside down. So it looks something like this, where the sides are all 3 triangle, all 3 here. 3, 3, 3. The height is actually 5. Okay, so base area is a triangle. Okay, base area is a triangle here. But bear in mind, okay, base area is a triangle. So this is actually, to get the base area, you find S first. S equal to half of A plus B plus C first. But each side is equal to 3 here. So this is half times 3 plus 3 plus 3, which is 9 over 2. So the base area here, base area is a triangle. It's S times S minus A, S minus B, S minus C. So you get 9 over 2, because S is 9 over 2 now. S minus A, so S 9 over 2, A is 3 here, B also 3, C was also 3. So this is actually 9 over 2. So this is actually 3/2 now. 3/2, 9/2 minus 3/2 here. Okay, then you press the calculator. This surface area first. So you can find that it's actually 3.897. There is a base area. So what is the volume now? Volume is base area times height, right? Base area is 3.897 if you calculate it. And then multiply by 5. Height is equal to 5. Okay, height is equal to 5 here. And then this will give you the volume is 19.5. So this one, the unit is all meter, so the meter cube here. Okay, so check the calculation because the answer is 19.5. You're supposed to get 19.5 or close to that. So this answer was part A. Okay, so this is volume is quite easy. Answer of part A here. So base area, I have a calculator. Let's use a different color here. So base area is yellow one. Base area you find out is this yellow one. So you put in, multiply together. This for part A. So I set this to you. Okay, so this is part A. I find the volume of a tank. Okay, then you copy the solution for part A. Okay, now I move on to part B now. Find the total surface area of the tank, which is in contact with water. Okay, total surface area. Okay, I want to find total surface area in contact with the tank. Okay, so next page, let's move on. Total surface area in contact with the tank. So remember, this is the open top. Okay, the top has no surface. Okay, that means that the top has no surface now. So the area in contact with the water is actually this surface here. So this surface, triangle surface, okay, triangle surface here. So there are two triangle surface. So total surface area here, total surface area now. So we're looking for part B now. There are two triangles, one in front, one at the back. Okay, then there's how many side area here? Okay, there is one side area. Which is a rectangle. Okay, C, B, E, F. So the C, B, E, F, and then another one at the back, also A, D, C, F. Okay, A, D, C, F. Here, so this A, D, C, F. Two triangle. So what is the area of a triangle? How do you find the area of a triangle? We actually find the area of a triangle earlier, which is 3.897. Okay, 3.897 is the area of a triangle. Here we find the area of a triangle, 3.897. So you can copy this one. So the first thing is 3.897, two of them. Okay, then how about area of the two square? So we know the square, this one is 3 here, this one is 5. Okay, given to you, one of them is 3 and 5, right? So this is actually 3 times 5 plus another 3 times 5. So now you calculate what is this now. You get 3.897, 3.897 times 2, two of them, plus 3 times 5 is 15, right? 15 and times 2. So you get 37.79. So 7.8 now. So this is surface area. So this is meter square, right? Okay, just now, let me see that mistake in here. Just now, meter cube, right? This is surface area meter square. So this is how you answer part B. Remember, the top has no surface. So the top has no surface. So you don't need to count A, B, D, E, right? So don't need to count. No need to calculate. Okay, no need to calculate A, D, B, E. So that's the sorry. No need to calculate A, D, E, B. So this is how you calculate the example 5 part B. So let me WhatsApp this to you here. Okay, so this is part B. Right, so I move on to next one now. Okay, now I'm going to talk about a round shape now. So talk about cylinder, right? So what is a cylinder? Cylinder you can see from there. Okay, you have a circle at the base, and the height here. So this is the cylinder. So how to find the volume of cylinder is base area times height, right? Base area is a circle, so pi r square is the area of a circle here. Okay, pi r square is the area of circle here. So this will be circle. The height is h here. Okay, so how do you find the surface area of a circle here? If you want to find surface area of a circle, you find that there is a two circle on top and bottom. So each of them is pi r square. So that's why you get pi r square by pi r square on the top and bottom there. And then the curved surface on the side. Then you have to know if you cut the curved surface, you cut it open, then roll it open now, you find that the height is h here, and the perimeter, the side now is 2 pi r here. So that's why you have this 2 pi r times h here, so 2 pi r is side here, okay, times height, okay, 2 pi r times height here. So this one I think I use in color yellow, height here. Okay, this is how you get the cylinder, right? So for this particular one, how to find the volume of a cylinder and surface area of a cylinder. So let me see what's up this video. Okay, then immediately we have an example to solve this problem. Okay. Okay, so this time we have open cylinder. What does it mean? The open cylinder tank, external diameter 4 and external height 8 here. A tank is made of 2 meter thick metal, 2 meter thick. Calculate the volume of the metal unit here. So what they want is actually the volume. They want the volume here. So first of all, what does mean by this open cylinder tank? Okay, open cylinder tank, what does it mean? So you look at open cylinder tank means basically it must be able to contain something, right? So basically you have to calculate the volume of this thing, right? So it must contain water, right? Open, that means there's no top. Okay, then basically this open here, no top. surface. All right, so this one is empty, no surface here. Let's try to look at the description. This one, external diameter is 4 and external height is 8 here. So you try to draw it first. So let's draw the picture. So this is the tank here. So this 8 and 4. So you try to draw it 8 here. Diameter is 8 here. Okay, sorry. Uh, the height diameter is 4 here, sorry. So diameter is 4 here. So this is 4. Okay, 4 meter. The height is 8 meter here. So draw it here. Which will show you the picture. So this 8 here. Okay, external diameter 4 and external height is 8 here. Then the tank has made of metal 2 cm thick. So they draw another picture here. Metal of 2 cm thick here. So I want to find the volume of metal here. So now what you do is cut the tank. You get a metal now. So let's see, I want to find this tank now. I go in, thickness is 2 mm, 2 cm here. So this is go inside the tank here. So if this is 2 here, 2 cm, so 2 cm means 0.02 meter. Meter, 2 cm, 0.02 meter here. So the inside radius is actually what now? Inside radius here, this is the diameter in this case is, initially is 4, now is 4 minus, now is 4 minus 0.02, 0.04, right? Because each side is deduct 0.02, so 0.04 now. Put this 0.04 also. So this is actually 3.96 meter now. And then because it's made of metal, thickness 0.2 cm here. So this one also cut across 0.02 meter. So you have another circle, another layer of circle here. Okay, so the volume of the metal required is actually find the volume of this side. So you have I want to find the volume. So what you do is take the total volume minus the volume of water here. So volume of water you take off. So you take the total cylinder minus the volume of water, then you already get the volume of matter required, right? So what is the volume of this? The base area times height here. So base area pi r square times height. Okay, first one pi r squared times pi here. So r is equal to 2 now because diameter is 4. So pi times 2 times square here. Diameter is 2, right? Diameter is 4. D is 4. So r is 2. 4. R is 2 now. The height is 8 here. So this one is 4 pi 32 pi. Okay, so this is the volume of the cylinder, whole cylinder. Now you deduct the volume of the water. Okay, so water volume here. Okay, pi r squared here. R is 3.06, 3.96 here. Divided by 2. Okay, diameter is 3.96. Now divide by 2 here. So 3.96 divided by 2 is the radius here. And this height, in this case, for height here is actually 8 minus 0.02 now is 7.98 now. Thickness 0.02 here. So 7.98 here. So this is 7.98 here. So let's try the press calculator and see what is this thing. So 3 pi here times 3.96 divided by 2 and square it. So I need a fraction. 3.96 divided by 2. Right, then square it here times 7.98. You know, the 8.28 here. And this one 32 times pi is actually 32 times pi here is equal to 100.53. Now you subtract them, you get 100.53 minus 98.28, you get 2.25 meter cube now. So this is how we find the volume of the metal required. Okay, you just minus the water volume from the tank volume, and then you get what is required for the metal required. This example 6 here.
Mr. Kwek,
Yes.
I don't understand how you get the 3.96 divided by 2 and also the 7.98 for the height.
Okay, let me see. Okay, so okay, first of all, how do you find the diameter? Estimate diameter of the tank is actually 4 meter. Okay, diameter of the tank is 4 meter first.
Okay, sorry.
Okay, 4 meter here. This one is diameter of a tank. Okay, diameter of tank is actually 4 meter. Then because the thickness, each side is 0.02. So minus 4 meter minus 0.02 one side. Okay, and then the other side is 0.02, right? So total diameter now is 3.96 now. Each side is 0.02, so it's 3.96 here. This is diameter. Then divide by 2 to get radius. And that's how we get this one. Right? And then also height also different because the top has no surface, bottom has a thickness 0.02. And so you end up 7.98 now. So as well, you get find the difference between this tank and the water volume. You get the solid you require.
Okay, Ken. Thank you, sir.
Okay. Okay, so this is example 6 here that you copy. See any question you still have, then you can answer. Okay, so I move on to the next one. We are going to talk about the next one now is actually sphere now. Okay, the sphere and the cone. Okay, the last example, example 7 now. The sphere of the volume of a sphere is 4/3 pi r cubed. Okay, then the surface area of a sphere is 4 pi r squared. So this is the sphere here. And then there's a sphere on the left hand side. So r is the radius of the sphere. So the sphere has a radius, just everything depends on the radius. The bigger the sphere, the bigger the surface area, the bigger the volume. Okay. Then the next one on the right hand side is a cone. And this one a bit harder to appreciate the cone. How does it look like? The cone usually have a circle at the base. Okay, circle at the base. So how to find the volume of a cone? We need the height. Okay, base area, 1/3 of base area times height. Base area is a circle. That's why I get 1/3 of base area times height here. So for the cone, base area, which is a circle, pi r squared. I don't know, I think no good here, change color. Okay, base area is a circle, so then you, okay, base area is a circle, so base area times height. The height for the cone is actually perpendicular height here. Then multiply by 1/3, right? So this is height here. There is also another called slant height. So the slant height is actually the side height here. So the slant height is actually this one. Okay, The sun height is actually this one. Okay, sun height is actually this one. Okay, sun height here. So this is called sun height here. So how to find the sun height? Actually, using right angle triangle, the sun height is the radius of the base times the height. That's the height here. Then you use Untitled 7 square root of r squared by a squared to get a sun height here. So why we want to find the sun height here? Because if you open up the part, okay, the part on the sector, you get something like this. Open up. V is a vertex here. V is a corner here. V, comma, the vertex here. The sun height here, and the area of this one is actually pi r l, where r is the radius of the circle at the base. The pi r l, r is the bottom at the base of the circle, radius r. So pi r l is this part, and this is the orange area, and then the side, there's an orange area, then the base is a circle, the pi r squared, right? So this is the thing about cone. Let me WhatsApp this to you. Okay, then we can actually look at the example. This example. Okay, I try to finish the example before 10. Okay, a buoyant consists of a cone and a hemisphere. Hemisphere means half sphere, shown in the diagram. The cone has perpendicular height of 0.3 and the base radius 0.4. That means is actually 0.4 is the base radius here. So this one is 0.4 here. From here to here is 0.4. The hemisphere also has a radius of 0.4, which is the same. Find the volume and surface area of the buoyant. Okay, so let's try to find the volume first. Okay, let's try to find, since they ask you volume, right? So let's try to find the volume first. So first thing is find the volume of cone first. Volume of cone, the cone is just something like this, right? Cone. Volume of cone plus the volume of hemisphere. So there are two things here. One of them is this one. The other is this one. I want a cone here. Okay, so we need to add them up together. Okay, how to find the volume of cone? There's a formula for this already. We know volume of cone. Okay, Just now I mentioned this already. Volume of a cone is 1/3 pi r squared times h here. Okay, 1/3 pi r squared per h. We see the volume of cone formula. Okay, volume of cone 1/3 pi r squared times h here. Okay, so that is easy. What is r here? R is actually r is equal to 0.4 radius on the base here. The problem is, do you know what is h here? Vertical height, right? So vertical height is 0.3. Okay, so this is actually, press the calculator first, okay? 1/3 times pi times r squared 0.4 square times height 0.3 0.005 0.05. So this is actually meter cube now. So that is the volume of the cone. How about volume of hemisphere? The volume of the sphere, volume of sphere is actually what? Volume of a complete sphere, right? It's actually okay, volume of sphere. We know for a sphere, looks something like this. Radius r. Volume of a sphere is 4/3 pi r cube. Okay. Formula again. Okay. 4/3 pi r cube is the volume of a sphere.
Shut the door.
Okay. Now, hemisphere is half sphere, right? So volume of hemisphere here, volume of hemisphere half sphere here, half of it now. So this is volume of hemisphere. It's half of it now. So half of this thing become 4/3 pi r cube here. It's a 2/3 pi r cube now. So we can get this one is a 2/3 pi r cube. So 2/3 pi r cube. R is 0.4 again. So we multiply them out. Okay, pi r cube here. Okay, so this 2/3 pi. So 2/3 times pi here times 0.4 power 3 0.134. So they add together, that's 0.05, and then you get 1.84, 0.184. So this is for part A. Find the volume. Okay. First part, find the volume. Okay. So this is how you find the volume. The volume of cone, the volume on a hemisphere. So put together, Look at this. So this is example 7, part A. Okay, so this is example part A. Now part B, you're going to clarify surface area, right? Part B, going to surface area, which is harder. Okay, so I will move on to part B now, surface area. So I want to find surface area now. Next one. So surface area have two of them. One of them is a cone. Okay, cone here. So there's a cone here. How to find the surface area of cone here? Okay, and then there's a sphere, hemisphere. Okay, so and then later on, then we add them up together. So there are two surface area. Okay, one of them is actually which surface is not counted, right? Remember, these are two joined together. They are joined together. So happen that this surface is not counted. Okay, this surface is not counted here. Same thing as this surface. So you need not to calculate the circle surface. Okay, you have to just the external surface only. So let's look at the cone here. So we know that this 0.3 here. So this height is 0.3. This radius 0.4 here. So this thing radius 0.4 here. So what is the side surface? The side surface actually, when you open up, you actually get something like this, a slant height here, L here. And this is a slant height. So when you open up this, there's a V here, the vertex here. So when you open up, it's something like this, surface, V, this is L, okay. The surface, which it look like the yellow part here, okay, is actually, according to the formula, we have to go back this one here. Okay, it's actually pi RL, the yellow part here, pi RL, okay. pi RL is a surface here. So this area is actually pi RL here. But then what is L? So L is equal to, using a right angle triangle, L equal to square root of R squared plus A squared. So it's equal to 0.4 square plus A squared 0.3. So this is actually 0.4 square. So there is 0.5. Let's check here. Okay. 0.09 plus 0.16. Then take a square root line. Answer 0.5. So pi RL is actually pi. R is actually from the picture is 0.4. L 0.5. So multiply this, you get pi here times 0.4 times 0.5. 1/3 of pi, and this is equal to 0.628 here. Okay, so this is the surface area. So this is actually meter square here for the cone. Okay, you cannot count the orange area because they are joined together, so can count surface area. Now how about the sphere? The area of the sphere, okay, surface area of sphere in this case, I want to count only this portion only, so don't need to count the circle 1. So only this one, hemisphere, right? So hemisphere, all of my surface area of hemisphere is equal to area of hemisphere because half sphere now. Now area of sphere is actually 4 pi r squared. Okay, 4 pi r squared. But this is half of the sphere now. So this is actually half of 4 pi r squared because area of space 4 pi r squared. Now half of it. So actually 2 pi r squared here. So this is 2 pi times r is 0.4 here. So 0.4 square. So we have 2 times pi times 0.4 squared. Right, you get 1.005. So total surface area, add them all together, is an orange, is this one plus this one. Okay, so you add them up together. So you get this one and the green color one. And you'll get 0.628 plus 1.00 by 3, get 1.63. So this is how you answer example 7. Okay, so this is the last example. Then tomorrow we'll continue the tutorial on 3D, right? Then next week we'll do revision. Okay, so this will be the end of the lesson. So tomorrow we'll continue. And let's see where Marcus, are you here today? Marcus, are you here today?
Yes, sir.
Okay. Are you able to take the retest tomorrow?
Yes, will do. Thank you.
Okay, tomorrow I see you. Okay. Right. Okay, you may leave now if no more issue.